Welcome to the second lesson on polynomials. First off, we're just going to review what we've covered last lesson. So polynomials are basically the sum of terms that have variables with exponents ranging from 0 in the case of constant numbers to pretty much infinity. For the purpose of this course, we'll be sticking to second degree polynomials, so x2 will be the highest that we'll be seeing and dealing with. So the example that's given here, we can just see that difference, that idea that we want to always consider polynomials as a sum. So even if it's a -7, we can still consider it as an addition of a negative number. So that's that plus -7 comes into play. To quickly review the vocabulary, polynomials do have certain characteristics. The number of terms and the degrees allow us to separate and determine which type of polynomial we're dealing with. We also do have coefficients, constant terms, and leading coefficient. So if we take a closer look at this polynomial right here, we will note this polynomial has 3 terms. The constant term, which is 13, 8p, and 6p to the 3. Now each of these terms do have a coefficient. We can take a look. The 6 and the 8 are the numerical values associated before the variable. Again, in that textbook definition, we could also as being a type of coefficient because it is understood that it would be 13p to the 0. Although it's not written down. We also do have exponents. So in this case, we would have the 3 would be the exponent of the first term. To a certain extent, we would also have the 0 in the constant term. And for the middle term, we would have p to the 1. So again, although the 1 is not actually written down, it is still understood that it is there. When we are looking to try and find the degree, we're going to be looking specifically at the exponents. We're going to be trying to find the highest exponent. So we can look at the 0, the 1, or the 3, realizing the highest exponent is the 3. So this polynomial would be a third degree polynomial. The leading coefficient in this case is that coefficient in front of the variable with the highest exponent. So in this case, it would be the 6. Quick review on how to use algebraic tiles again. We'll take a different polynomial this time, 5x2 plus 4x minus 22. We'll take a look at first how many x2 tiles we need. So we know these are these square tiles. And the coefficient in front of us will tell us how many tiles we need. In this case, 5. We'll then move on to another term. Seeing as there's no negative numbers, we don't need to switch the tiles over. We'll move on to the second term, which in this case is 4x. So we'll be using the x tiles, or the rectangles, and the coefficient will tell us again we need 4 of them. We'll now move on to the last term, which is the constant term. We know it's a -22 because it's an addition of a negative number. So we'll be using, for the constant term, the little tiny square tiles. However, it's important to remember that because this number is negative, the tiles will be flipped on the red side for a negative number. And again, we need 22 of these little tiles. And now we have successfully represented our polynomial using algebraic tiles. Thank you very much. I hope this helped to clarify anything that was still left unclarified.